We're at Kettering University Electrical and Computer Engineering Department. Our senior design project for 2011 summer was to design a small horizontal Axis Wind Turbine, which performs at that charges a 12-volt lead-acid battery and runs at 24 watts at 15 miles per hour, having a rectified DC voltage of 20 volts. Our groups consisted of the turbine group, which is responsible for rectifier and regulator, the alternator group, which is responsible for the stator and the rotor, and the DAC group, who is responsible for data acquisition.
I'm Don Yocum. I'm part of the turbine group, and I was in charge of designing the blades. We went with a 3-blade system made out of 4-inch PVC, Schedule 40. We used 2.5-foot blades as a compromise between the RPMs and for the manageability. We didn't want them too long, so we wouldn't have to carry them around. I used a MATLAB program to determine the rib length at every point, and then we cut it out with a jigsaw. I used 4-inch strips of aluminum 1/8 inch thick to attach the blades to the hub right here, and then the hub slides on the shaft in the alternator with a single set screw, and it's easily taken off.
Hi, my name is Sam Bowen, and I was part of the alternator group for the wind turbine project. Everything that you can see here was designed and built by our team. In the middle we have our stator, which is cast out of fiberglass resin, and it contains 9 coils, each containing 30 windings, all done with 18-gauge magnet wire, and it's configured in a 3-phase Y configuration. And on the outside there is a 1/4-inch steel plate with 24 magnets, 12 per side. And for the output for the alternator, we calculated at 420 RPMs, we should have an output of about 13.37 volts.
Hello, my name is Nelson Wong. I'm part of the turbine group. I'm going to talk about rectifier circuit and regulator circuit. The rectifier circuit consists of 6 jockey dials with a feature of low voltage drop and to provide high power efficiency. We test the open circuit at 20 volt DC with 96% above efficiency. And the regulator we choose is UA 7815 volt with 13 volt to 35 volt input DC and 15 volt output. And the maximum current can handle is 1.5 amps. We collect 6 together to give the capability of 9 amps totally. We use a balancing resistor to protect the circuit and provide around 14.5 volts to charge the battery.
I'm Mike Badgerman, and I was part of the data acquisition group. We developed a program using LabVIEW to take measurement of temperature, the load voltage, the DC current, and the wind velocity and the wind direction. And we use those to calculate the air density, the available wind power, the output power, and the overall efficiency of the device. We use this anemometer and this wind vane. We're not given a data sheet for it, so we characterized it and used the NIDAC to interface with the computer.